All right, here I'm going to work out the check your understanding problem so you have that information. First problem from the book gives us a point 0, 0. It says tell whether the ordered pair is a solution of the given system, and the system is y greater than negative x minus 1 and y less than 2x plus 4. I'll check this in the first equation. And that'd give me a 0 is bigger than negative 0 minus 1. 0 is bigger than negative 1. If I try it in the second equation, I get 0 is less than 0 plus 4. And 0 is smaller than 4. So yes, 0, 0 is a solution to that system. Problem number 17. They give me the point 0, 0 again. And the system is x plus y equals, or not equals, sorry, is less than 3. And y greater than 3x minus 4. So we'll test the first equation, put the zeros in, I get 0 plus 0 is less than 3. 0 is less than 3, that's true. If I put the zeros in here, it says 0 is bigger than 0 minus 4. It is not, so the answer here is that this is, tell whether it is not a solution. Okay. Problem number 21. Graph each system of linear inequalities, give 2 ordered pairs that are solutions and 2 that are not solutions. Okay. So my system in 21 is y is greater than 2x plus 4 and 6x plus 2y is greater than or equal to negative 2. Okay, I'm going to graph that system. I'm kind of working on a piece of graph paper here, so draw myself bit of a grid, and we'll see what we need. Okay. 2x plus 4 is going to intersect at 4. It's got a slope of 2. That's up 2 over 1 or down 2 left 1, and that is a less than there, so this is going to get a dotted line going through these points. The other one, 6x plus 2y is greater than negative 2. I'm going to make a table for that one. I'll pick some y values, I think. No, I'll pick x values. I'll pick an x of 0. When x is 0, I get 2y here and a negative 2, so y would be negative 1. So 0, negative 1 is on that one. And if I pick a y to be 1, then I'm going to get 6x plus 2 is negative 2. I'm using equals because I'm finding the boundary line. So 6x, oh, not that. I put a 1 in for the x. So that's 6 plus 2y is negative 2. Subtract a 6 from both sides. 2y will be negative 8. Divide by negative 2, and y will be 4. So 1, 4 is on that one as well. And so that's going to be a solid line going through those. And it's not looking like I'm going to get all the way up to where those would intersect, but pretty close up there somewhere. Now, I didn't do my shading yet. So my first one, 0, 0 is not on this first line. If I put 0 in, just like I did in the previous problems, it would say 0 is bigger than 4, which is false. So for the dotted line, my shading should happen up here. I don't want to cover up the 0, 0. And for my other line, it also doesn't pass through 0, 0, but if I put 0 and 0 in there, I get 0 is greater than or equal to negative 2, which is true. So I'm going to shade that side of that one. Now I'll go very lightly here. So I'm covering up the 0, 0 on my shading here, and then it is up on this part going to overlap with my other one. So I've got up here and over here is my correct answers. So it wants 2 correct answers, 2 ordered pairs that are solutions, and 2 that are not solutions. Anything that is clear here that's not shaded by this dark one is a non-solution. So 0, 0, for example, is a non-solution. 2, 2 right here is a non-solution as well. Ones that are solutions, this point and this point would work. So that looks like negative 2, 1 and negative 2, 2 will both work for that one. Okay. Probably should have given myself a little bit bigger graph space to do that on. I'll try to adjust that for problem number 22. The system it's giving me there is 9x plus 3y is less than or equal to 6, and y is greater than x. Now somehow I got a feeling I'll be able to get this in a little bit smaller one this time, so I'm not going to make any adjustments that way. Okay, 9x plus 3y is less than or equal to 6. I think I'm going to try to put that into slope-intercept form. Subtract a 9x from both sides. I'm going to get 3y is less than or equal to negative 9x plus 6. And then I will just divide everything by 3 and get y is less than or equal to negative 3x plus 2. So that's a y-intercept of 2, slope of negative 3, solid line. Test the point 0, 0. It says 0 less than or equal to 6 when I do that, so 0, 0 should get shaded. So that's shaded on that side. Line y equals x has a y-intercept of 0 and a slope of 1. The 1 in front of that x means up 1 over 1. So I'll line up slope of 1 here. This line is dotted. In this case, on my shading, it doesn't work to pick 0, 0 because 0, 0 is on the line. So I will pick something else. Like if I pick this point right here, this is the point 2, 0. I'll put a 2 in for x and a 0 for y, and it would say 0 is bigger than 2, which it is not. So I should not be shading on that side of the dotted line. I should be shading on this side of the dotted line, which is going to overlap with that other one. And this is going to be where my good answers are. So I'll call them solutions this time, and not solutions. Well, that 2, 0 is definitely a not solution. I could pick this point out here. This one is really a not solution. That's negative 2, 1. Doesn't work for either one of them. Solutions in here, I've got a point there. I could use that. That's at 0, 1. And any other point up here in the shaded, that looks like it's at 2, 4. That would be a solution as well. I'm going to pause here, make this the video just for those first 4 problems so I don't get too long on anything.